Hello, and welcome to the last session of this year's Devtoberfest Data and Analytics Week. This is last but one week of Devtoberfest. My name is Vitaly Rudnitsky. I'm the host of this week, and I really would like to thank you for joining this last session. Before we switch to the session, I just wanted to quickly remind what we had during this week. It was pretty packed program. We kicked this off with two presentations on Tuesday: demystifying data science in the enterprise and the modern enterprise data landscape. These sessions, including one more session that I presented yesterday on data visualization, are available on YouTube on our SAP developers channel. Obviously, this session is going to be available there as well. On Wednesday, we had two fantastic discussions with multiple authors who wrote books on the topic of SAP data and analytics. These sessions, as well as the Ask the Expert Data Science in Practice session, are available on SAP developers channel as well. Besides just presentations and discussions, we did have multiple tutorials for you to go through in case you are interested to practice any of the relevant technologies like SAP HANA Cloud or SAP AI business services. These tutorials are available outside of this week, obviously, as well. Plus, we had relatively simple, but hopefully interesting coding challenge where you would work with SAP geospatial data representing SAP Waldorf campus. And now we are on the last session of this week. As I mentioned, this is Fun Friday activity. Today morning, Jens introduced us into what it takes to design the programming language for all children. And he presented Snap, an interactive visual programming language. And now we are going to have another session about Snap, but this time discussing programming beauty and joy. This title sounds really interesting, and I'm waiting to learn as well how Snap can be used for that. Jadga, Jens, the stage is yours.
Thank you, Vitaly. So great that you're all here. As Vitaly already mentioned, today we want to talk about how to bring beauty and joy to kids while they learn computer science. And it's also about attracting non-traditional audiences. So we want to show how to make more artsy projects. So let me share my screen first. This is what we're going to talk about. A square. So Jens and I decided that it would be a cool idea to have a really simple building block like a square, and to see what you can come up with on different variety on projects that different people might be interested in. As Vitaly already mentioned, it will be a little bit about generative art, so classical algorithmic art. Jens is showing a project about a famous artwork, but we'll start with a pretty simple exercise on how we can actually create a square. So if you want to follow along, now is the time to go to snap.berkeley.edu and click on Run Snap. If you want to watch right now and want to try everything out later, lean back and just watch me and Jens program things, and you can follow along with the video later on. Okay, here's a new Snap window. I hope most of you watched Jens's presentation this morning, but for those who missed it, real quick, Snap is a visual programming language, which means you program by dragging and dropping these coding blocks, which we call blocks, together in that center field of my window, which we call the scripting area. The blocks are ordered in different categories. So motion, the blue blocks, means that they have to do with the motion of the object that we're programming, the sprite on the stage. So let me drop something in here. For example, move 10 and turn 15 together. Whenever I execute that part of the script, executing, meaning I click on it, you see that my object actually performs these actions. So it moves 10 steps and then it turns 15 degrees. So this is how you program. And of course, you can stack these blocks together to more complex scripts that also interact with each other. But let's start new. So this is how your window should look like. And as I said, we want to start by programming a square that we can then use for different programming ideas later on. So we'll start with moving and turning blocks. This is also a pretty cool introductory activity because you can actually have kids walk around, or young adults, people who don't know programming yet, walk around in the classroom or in the facility they are in and actually try to rebuild the algorithm in their head. So when you do that in a turtle geometry way, you would move forward and then it would turn 90 degrees and you would move forward again and turn 90 degrees again. So 4 times. Let me do that real quick. So it's move, let's do 100 steps and turn 90 degrees. And we do that same thing 4 times. Let me also put the pen down. This is a pretty cool feature in Snap and Scratch. So you can put the pen down and you can think of your object that you're programming, the sprite, as a little robot who has a pen at its tip. And whenever the pen is down and you move around, the object draws everything that it moves. And when you have the pen up again, it just moves without drawing. So now I clicked on pen down. You can also see that the pen is down by checking that checkbox here. And then you see it on the stage. And now when I click on that script, you see that the sprite moves 4 times and turns 90 degrees in between. What we did now is the exact same script 4 times. So 4 times move and turn. So we can use a loop for that. In the control category, you can find different loops. In this case, we want to use the repeat a specific number of times loop. So this has 10 as a default, but we only want to repeat 4 times. And the part that we want to repeat is move 100 steps and turn 90 degrees. So let me clear the stage first. The clear block is the first one in the pen category, and it erases everything that you've drawn on the stage. So I'll put the pen down again and do the same thing. So this happens to be the exact same, or this leads to the exact same result as this script, but it's way shorter and much easier to read. So now we want to reuse that square more often. So let's build a block for it. In Snap, you can build your own blocks by clicking on the plus sign here at the top in each category, or by clicking the Make a Block button at the bottom of each category, or by right-clicking the scripting area and selecting Make a Block. I prefer the plus sign here, but it's up to you what you want to do. When you click on that, you get to a block editor where you can first select a name for your block. So in this case, I'm going to choose square because my block is supposed to draw a square. And then you can decide what type of block you want. So the puzzle piece shaped blocks are commands, which mean they tell the object to do something. There's also other blocks like reporter blocks. They report values, and predicates are a special form of reporter blocks. They only report true or false. But right now we want the object to do something, or the block to tell the object to do something. So we're going to leave it as a command block. And then you can also select whether you want this block to be available for all sprites, if you have more than one sprite in your project, or for this sprite only. And I will do it for all sprites. We might want to use it in another sprite later on as well. If you click OK, you already have the block here in the bottom of the category that you put it in. And here you can see that you have a so-called block header. It's a head block with the block prototype written on it. And now you can program what your block is supposed to do right below. So I already prepared this here. I can drag it here, click apply. If you click apply, the block editor stays open and you save or store what you've changed. If you click OK, it stores what you've done and closes the block editor, but you can always reopen it by right-clicking on your custom block and selecting edit so you can get back to the block editor. So let's try whether this works. So if I click on the square block now, it's supposed to draw the exact same square that I had before. Great, this works. We could also include a pen down, pen up block right in the square block, so we don't have any artifacts while moving or when moving the block to somewhere different. So let me move the block somewhere, let me move the sprite somewhere, and you see that since I have the pen down, I'm drawing everything that my sprite moves. So let's just include the pen down block in here, and let's also include a pen up block after we've done drawing the square. And let's click OK, and let's retry this. So now let's try moving the sprite somewhere else. This works, and now it's not drawing anymore. So we have our square block now, and we can use it to do things. So for example, we could draw a mandala from squares, meaning different squares in a circle. So let's grab another one of those repeat loops here. And let's say we want to draw 10 squares or a circle of 10 squares. This means we have to, so if I do it like that, I'm just getting 10 squares at the exact same position, which is not what I wanted, but I wanted the sprite to turn in between. So let's grab a turn block and let's find out the right angle that we need to turn. Most of you might already have guessed it. It's 360 degrees. So the full turtle trip, full circle, divided by the number of squares that I want. So we can use the division block as an input. And right now it's 360 divided by 10. So let's try this. But I could now also change it to 7, and I would need to adjust that here. And now it would draw a circle from 7 squares. If we wanted to do a more complex mandala, it might be a cool idea to adjust the square block. So it also takes, it also has a parameter, and it takes different input values, so I can make differently sized squares. So let's go back to the motion category and let's edit the square block. So if I click on right click and edit, I can add an input slot here. Yeah, there's these small plus signs next to each title text. And if you click on them, you get a pop-up where you can decide whether you want to extend the title text of the block or whether you want to add an input. In this case, I want to add an input. I'm going to call it size. And now I get this orange blob. And if I click apply, you see that the block also changed. So when I want to draw a, what did I have? 100 before, let's try 50. So when I want to draw smaller squares now, the number that I input here is stored in that orange blob in the block. So the size variable or parameter now has the value stored that I used as an input here, so 50. Now I also need to use that orange blob as a reference in the move block. So let's click apply again, and let's try this. So now I got a smaller mandala. And now we can try to do something a little more complex. So for example, we could do larger, or we could do that randomly even. Let's try randomly. So let's repeat it 10 times, and let's make randomly sized squares. So for example, I could input that pick random block, and I want the size of my squares to be between 20 and 100. And if I do it like that now, I get differently sized squares. Or for example, I could change the thickness of the pen. So the pen size is by default 1, but I could also increase the pen size to something larger. Let's do 15 maybe. And then I could draw 10 squares with size 100. And this would look like that. And then I could change the pen color to, well, let's do light green, like all the hackers do. And then we could draw another round of squares on top of that. So for example, we could draw 5 squares with size 80 and maybe with the smaller pen size on top of that. So this looks a little more interesting. So this is fun activities that you can do with the square block that I just built. And I'm now going to hand over to Jens, and he's going to show you how you can do actual great computer art with that.
Thank you, Jadga, and hi everybody from me. So you've all got your square block, and as Jadga and I were talking about this as we prepared it, we thought, you know, if we do art, that's okay, but we're not really artists. There are people who are actual artists who make generative art, and what if we just copy what they did? Maybe not copy it, but maybe remix it. And this is an idea that we got from our friend Joachim Wedekind, who is an educator and artist right next to where I live, right in Tübingen. And Joachim introduced us to the artist Georg Nies, who I think it was in 1969, produced a very simple painting, a very simple drawing, really, based on squares that has become an iconic piece of generative art. And I'd like to invite you and show you now how we can play with that. So let me share my screen. So I've been following along Jadga with the square block. Here's square block, and I hope you have it too. I'm going to close this. And the first thing that I'm trying to do is make a grid of squares onto the stage. And I'm not going to be very fancy about it. I'm just going to code this straight down. First, let's move the sprite up, set the Y position to somewhere close to the top. Let's see, that's 175. That's way up to the top. We can set the X position to minus 175. So now we're kind of having sort of a square area that we can go to. And we want to make rows of these squares. So we're just going to take the repeat block and say, okay, let's repeat, 14 times, draw a square of 20, and then change the X position by a little more than 20, so there's a little space in between these, by 25. So that's for one row. Let's actually try this. Yep, this works. Let's clear it again and go back. So now we want to go to the next row. So we're going to have another repeat block. Again, I'm going to repeat 14 times. And what we're going to repeat is we're going to set X, again, back to minus 145. And we're going to change the Y position. We're going to go down with it. So by minus 25. And now all we need to do is, we already got the square. Let's actually try this. So set it to minus 45, clear it, and run it. And so now we're drawing sort of a wall of squares. It's kind of nice. I like it. I guess if you squint, you might be able to see some. No, maybe that was something else. So this is okay, but it's not really that artsy. So now one idea was to maybe change the way the orientation of these blocks based on the row. So we're going to make a little variable, and that variable, I'm going to call it tilt. And the idea is that whenever we're drawing a square, we're tilting it by some random amount. So we can say we're going to turn it by a random, so it could be either to the right or to the left, we're going to tilt it. So we're going to tilt it from negative tilt to tilt. Then we're going to draw the square, and that's it. Now, since we always want to turn it from a fixed position, so it really only turns within the bounds that we define, we want to make sure to, before we tilt it, to reset it to its default direction. Now we're not ever setting the tilt variable, so the idea would be to set it depending on how far we go down in that row. So we could do that at every row. When we reset it, we could increment the tilt by 1. Let's try this out. So it starts straight, and now you can already see that there are some variations, just very subtly visible. The more I go down, the more crooked they become. This is sort of the basic idea behind the artwork Schotter. And what's cool about this now is that now you can actually play with various parameters. And Joachim has actually written a whole book about these things. I'm really recommending you to read his books. I found out that, for example, if I use 4, that already looks like something that is interesting to me. And another thing that I'd like to do is I kind of like to hide the sprite so it doesn't always get in my way. So I'm hiding the sprite. I can just click on the hide block. Now I'm just seeing the squares. And another thing that we can do is we can make this run faster by wrapping a warp block around the outer repeat. And now every time we click on this, we instantly get a new picture. And now we can, for example, try, what about 6? Oh, now it kind of gets very messy. We can attach the green flag to this, put the hide block on top, and there we have our homage to Georg Nies. I'm inviting you to maybe try different things. Now you could also try with colors, depending on the tilt. Maybe you could try with different shapes. But this is basically the idea behind the iconic artwork Schotter by Georg Nies. I'm going to hand it over now to Jadga to keep you along the path of art and beauty.
Thanks, Jens. So this is a pretty traditional generative artwork. Let me share my screen again. So here's a original version that I just found online, and this looks pretty much like the one Jens just built. So it's really great to discover those oldish artworks. So this one is apparently from the 80s. And to try to find out how they were actually built, because for most of those generative art things or algorithmic art things, the code is lost, but you can of course try to remix it, and we have way better machines today, so we might even find more elegant or cooler ways to do it. And then I just wanted to show my party version real quick. So this is a version of Schotter that I built, where I draw the thing new each time, and I'm measuring the frequency in my microphone. So you can see that here, this uses the microphone of my laptop, and based on the frequency, it sets the color of the artwork. So this is the party version of it that also uses the power of modern computers. So this is a project that's fun experimenting with. Okay. So let's go back to what I've built before, and let's reuse the square block for more things. Right now, we really did generative artworks with just the computer and the stage, and now we want to include a photograph as well. A really cool feature of Snap is that you can actually wear photographs of yourself that you can take, snapshots that you can take with the webcam as costumes for your object. We haven't talked about costumes before, so by default, your object looks like this arrowhead, which we call the turtle, as a reference to logo. But you can also draw costumes or take a snapshot with the camera, and your object will wear that then. So let me take a picture. And now I have that. Oh, I need another sprite. Anyways, let me copy that. So here's my, here's the photo that I just took. let's move that to the center of the stage. Great. And I need another sprite with the photo. So let's copy that over there. And let's remove it from here. So the idea is that we take that picture now and redraw it with squares. The underlying idea is in an art form called pointillism, where you draw everything from just dots. And usually, I mean, some of us did something like pointillism in primary school, where we, for example, had to draw a scenery with just dots in different colors. But this is a pretty advanced art form that came after Impressionism and looks pretty cool. And we can use that to redraw a photo in Snap with just the squares that we built. So we can measure the, let me move that sprite to the top. We can measure the colors in another sprite or at the mouse position or at the position of another sprite with a block from the sensing category. So this is my mandala stuff. I'm just going to move it over here. And I'm going to start over here. So with the hue block, hue at mouse pointer, you can find out stuff about colors in other parts of your projects. So for example, let me wrap a say block around it forever. Say the hue and mouse pointer. So when I move around, my sprite can now say the hue. So the yellow forever block has a hue of 11. The purple blocks from the looks category have 73. The green blocks from the pen category 45. So this uses the HSV color model, HSV meaning hue, saturation, and value, which we call brightness. So this is a color model made from 3 components, where the color is the hue is the value that you pick along that line here. So a hue of 0 is red, and a hue of 100 is red as well. And then you have 2 other dimensions. The saturation is there for, how do I say it? The intensity of the color. So how much actual color or actual hue you have in your final color. If the saturation is really low, you get to grayish pastel white colors. If your saturation is pretty high, you have intense colors with a lot of hue in them. And the third dimension is the brightness or value, meaning the amount of light that is in your color. So if you have 0 light in your color and the brightness is 0, your color is black. And then depending on how much light you add, you're going to end up somewhere at the center with pretty intense, pretty bright colors. So let's stop saying that. And let's use that hue block to measure the hue, saturation, and color in the photo. So I can measure the hue at sprite 2, which is the photo. And for example, let's move the sprite over here to that red flower, and let's click on it. And I'm expecting that it's going to be something close to 1, 0, or close to 100, because that's what red values are. And it's, oh wait, I needed you at myself, I'm sorry. And it's 3.6, so this is pretty close to 0. That's what I've expected. And then let's maybe move it, I don't know, to my hair. And let's check the brightness there. So that's pretty dark, and we expect a low value. So that's 15. That also seems to work. And now we can use that to actually set the pen color to the values that we measure here. So I set the pen hue to the hue that I'm measuring at myself, and I'm setting the pen saturation to the saturation at the sprite's position, and I'm setting the brightness to the brightness at that position. So let's try that. When I click, I'm now expecting the sprite to become pretty dark, like my hair. Okay, and let's also try it on my yellow scarf. Yeah, brown scarf. This works as well. Okay, and now we can use that to let our sprite move around the stage with the go to random position block. And wherever we are, we want to draw a square on the stage. So let's use the square block, and let's use a small input, maybe like 5-ish. And maybe let's increase the pen size a little bit. So we set the pen size to 3. And let's try that. I can click that, I can click that. So it's now moving around the stage and it's drawing squares everywhere. I can't see that because my image is in front of the stage, but we can just make it transparent by setting the ghost effect to 100. So now my image is transparent and you see that I've drawn differently colored squares on the stage. So let's wrap forever around that. So it does that automatically and I don't have to click all the time. And you see that the sprite now moves around the stage and draws everything in squares. We can try to speed that up a little bit by turning on the turbo mode. And you see that it's a lot faster. And this is my face actually all drawn from squares. So this is pretty interesting. And you can use that to recreate your holiday pictures or whatever you like. And it looks a little bit like when you stitch on these stitching frames where you always have these square-ish structures as well. So that's another fun activity that you could do just with squares. This also looks great with dots or words or other shapes. You can also, that looks pretty nice. Let me change the pen transparency as well. So there was a fourth value in the pen hue block, which is not part of the actual color model, but it's the transparency of the pen. And if we set the pen transparency to 80 and try this again, you see that you have it looks like a little bit softer maybe, and also pretty interesting. So adding different transparency values is also a great idea. Okay, and then I wanted to show one more thing because you can also, no, wait, let me show that first. So I prepared another project that I've done in a workshop that was about environmental data. It's not that much data, it's just 6 animals, but it's 6 animal species with the number of individuals still left for that species. So we have the leopard, which has still 12,000 individuals left, and we have the North Atlantic right whale, which is a pretty big whale that lives around Canada, with only 320 individuals left. And then we have, for example, the giant ibis, which is a bird, a huge bird that only has 200 individuals left, so it's probably going extinct pretty soon. And this is a project that draws the animal or an image of the animal with squares, and the number of squares on the stage is the number of individuals that's still left from that species. So that's pretty cool because you can see for the giant, this is the giant ibis, by the way, for this giant ibis bird, you can see any individual, every individual is one of these squares, and you can't see the bird literally because there's no individuals left. This is a visualization that was once done by WWF Japan that even won some prizes. So here, for example, is the leopard with 12,000 individuals. Here we have the right whale with only 320. So that's also a pretty cool application of just squares that looks great and also has a great meaning. And I wanted to show that as well. Okay, then I wanted to show one more feature of Snap that I love, and it's the pen trails thing. So let me draw one more square. It doesn't really matter which one. Let's just do, maybe let's use another pen color. And let's use this, and let's draw a square. And with the pen trails feature, you can actually use what you've drawn on the stage as a thing in your programming language. So I could now switch. So my object is this arrowhead thing. And I could now, for example, switch to the costume of the pen trails. And now my object looks like the square that I've just drawn. So this is my object, and this was what I've drawn on the stage. So using the pen trails is a pretty cool way to also interact with what you've drawn. And you can even add them as permanent costumes to your costumes library. So let me show that real quick. You can access all costumes of your sprite with the My block. This is like the most powerful thing in Snap, which has all features and attributes of all sprites and everything. And you can access it from there. For example, you can see every costume that a sprite has. This one doesn't have any, so you can't see anything. But now I could, for example, add the pen trails to this list of my costumes. And if I click on that, it'll add a permanent version of my square to the costumes. So let's draw another square. If I add the pen trails now, I have both squares. So this is the new costume, which when if I switch to that, you see that you can also create pretty interesting. So which one was the, I lost it. Okay, so one of them is the sprite and the other one is the drawing. And you can create pretty interesting artifacts by just copying it and turning the object without having to draw everything. So that's pretty cool as well. But what I wanted to do or wanted to show now is one project where we use this square that we've just drawn. Let me make a bigger one with a larger pen size. And let's add that to the pen trails as well. And let's switch to that and let's clear. So we can now use this as a prototype for our clones that we can make. And then we want the clones to fall down from the stage. And when they reach the bottom of the stage, or when they touch the pen trails that we will create in a minute, then the object will stamp itself at that position. So we can create some kind of a sedimentation project. Let me just show you. So we have this object and we want to clone this object. So there's in the control category right at the bottom, you can find blocks where you can create clones of objects. Clones meaning you just create another instance of that object. So here now I have two. This is the one that I just cloned, and the other one is the object, and I can clone it again. Oh, this one was the original one. Group. So I have here my object, and these are the two clones. You can delete these non-permanent clones by just clicking on the stop sign at the top. So we now want to permanently create clones. Let's wrap a forever loop around it and maybe a wait block so it doesn't take that long. Or it doesn't go so fast. Now I'm forever creating clones, and they are all at the same position that the original object was at. So that's not what we want. We want the object to go outside of the stage. So let's do Y 230 maybe, a little bit more, 240. So now we move the object outside the stage and we're creating clones. And now we can model what we want for each clone to happen. So there's a block which is called when I start as a clone. So this is a head block. We haven't covered those yet. Head blocks means that you can't attach something on top of the block, but just at the bottom. And whenever what's written on the head block happens, the script below that head block is triggered. So in this case, whenever I create a clone of that object, this head block gets triggered. So now we can model what we want for all clones to happen. As I said, we want them to fall down. So, and we want to do that based on a condition. So let's grab one of those repeat until blocks. And what we want to repeat is we want to change the Y position of our object by a negative value. And we want to do that until we reach the bottom of the stage or touch the pen trails. So there's a touching block here in the sensing category, which has pen trails as an input option. And then there's the OR block in the operators category. So this is one of the conditions. And the other one is the Y value is smaller than negative 180, for example. That's the bottom of the stage. So let's grab this one. The Y value of a sprite is smaller than negative 180. So let's try that. We create clones and they fall down. I still have the turbo mode on. This is why this looks so fast. So we have now, we create clones and they fall to the bottom of the stage, and that's it. So this is not what we wanted, but it's a pretty good start. So afterwards, we want to stamp the clones. And then we also want to delete them. So let's try this again. We clone something. Whenever we reach the bottom, it should stop and it should stamp something. And now it doesn't move because every clone is touching pen trails right when it starts. So we can't see a difference anymore. And now we can try to make this a little more beautiful by, for example, setting the size randomly for each clone. So I set the size randomly to, let's say, 20 to 40. Let's clear the stage here as well. Let's try this again. So now I have differently sized clones. And then let's also make the color a little bit different. So we can set the color effect to a random value as well, between 0 and 200. So we get differently colored clones. So now I have green, red, blah, blah. You can see that. Okay, great. Okay, and then we could also distribute them along the stage. So let's have a random x value. So they start not all at the same x position, but at a different one. Let's try this. So we set x randomly between minus 240 and 240. Let's try this. Why are they not stamped? Okay, anyways, and I can show you the version that worked. And then we could also turn them a little bit. So let's try that as well. So we can point in a random direction before we start creating them so that they all look in a different direction. Now it works. So you see that some of them are touching the bottom and then they stop. And then when they touch the pen trails, they'll also stop and stamp themselves. And when we look at the pen trails now, you see that right now it's that sedimentation thing that we just do, and it's still growing. And we're still cloning and it's still growing, and it would fill up until every part of the top here is also covered with clones. And this is also pretty interesting because we added a lot of randomness. When I start that new now, let's try this, we will get a similar style, but a different version of the project. And this is true for all these algorithmic artworks. Most of them are unique because you most likely will never get the exact same random values again. So all of them have the same style, but a different outcome, which is pretty cool, I think. So this is also something that you could do with the square block that we just built by using the result of the square block, so the pen trails, as a costume for other objects that you can then clone. Okay.
Jadga?
Yeah.
So just a quick question, actually, in the chat, Andrew Diaz is asking, is it possible to save then this as a GIF or MP4?
Not from Snap. I mean, you could just make a screencast, of course, streaming that, or you could take the pen trails. So I could store the pen trails every, I don't know, 1 or 2 seconds. So let's just try that real quick, actually. So I have this pen trails block here, and I could just add the pen trails to my costumes every. Wait. Okay. Wow, my computer's pretty slow. So forever, let's add the pen trails to my costumes, and then let's wait a second or so. Maybe let's even wait 2 seconds. We're just demonstrating it. So I can start that now, and I can start that as well. And you can see that now it should add the pen trails. Now we don't have any pen trails yet, but now we should have these pen trails here. And I can, they change. Of course, this is way slower because I'm always taking the pictures, but you could just run that for a while and then let me stop that. So I can, let me delete those first 3. I mean, this is basically what a GIF is. So I could now animate these by just forever switching to the next costume. and then maybe wait a little bit in between so we can see the difference. Okay, let's check that. Oh, wait, let's clear the stage first. We'll see whether that works. Okay, this should work.
Maybe you should move it to the middle of the
right, my object
and
is at the top.
make it point to the right.
You're right. My object is here at the center, but because my pen trails are out there, right? Okay. Okay, we would need to move the object to a different position, but actually you see that I have all those costumes here because actually the center of the costume is not at the center of the stage now anymore because I moved my costume up there. Anyways, you can store that and you can replay it then again. Just make sure that the center of your costume also is at the center of the stage then when you do that.
And thank you so much for trying, because this is live programming, right? That's absolutely brilliant.
You're welcome. Okay, so Jens now would show you an advanced version of what you can do with the square, a fractal. So right now we covered doing a simple square, drawing a mandala from that, using it to interact with media, using it for clones to create an animation of a simulation, so some sedimentation project. And now Jens would show you a fractal, so a recursive version of what you can do with the square.
Thank you, Jadga. Yes, fractals are cool. Recursion rocks. I love recursion. So I can't wait to show you one more thing you can do with the square. Hey, did you know you can do so many things with the square? So I'm just going to make the square block again slightly different. Basically, it's going to be a square of a size, and we made the size to be an input. You could say it's a number, doesn't matter. And so what we do is, we'd repeat 4 times to move the size and turn 90 degrees. So we get the total turtle trip. And this is basically our square block without drawing anything. So I'm applying this. I can now draw a square of 100. In order to draw it, I'm going to use the pen down here and then the pen up again. So here's my square block. Big deal, you've done it. So now the cool thing is, whenever we see something like this, there's a question like, here's the square block sitting in there. And here's this little, block editor that also has a scripting area. What happens if we take the square block and drag it inside and use it there? By the way, another way you can do this is you can actually drag it off from here. Already, we're kind of suggesting you use it inside. So what if before we even draw a square, we draw another square? And to see it, we're drawing another square at the half of the size. So now it's sort of a square of squares. Let's try this. Let's clear it. And let's draw the square of squares and see what comes out of it. Nothing. How come that nothing comes out of it? Because before it even draws something, it tries to already draw something else. So clearly at some point, it never stops. So whenever we have something that is a fractal, say this is a fractal, whenever we have something that is recursive, we need to define a base case, a condition where the recursion stops. Now a condition, that's a conditional, so we can use the if block. We can wrap that around here. There are various ways to define a stop condition. Often when you define a fractal, you count the levels of recursion, and then you say, you count down. Here, I'm just going to say if the size that's left is bigger than, let's say something reasonable like 10, it should stop. Let's try it now. And now what's happening is we're actually getting something that is a square of squares. It's not very interesting. Basically a fancy way to just make a square paper. So how can we make this a little bit more interesting? Well, we could make a bigger square, but we could try to do something before we draw the inner fractal. What if before we draw the inner fractal, we turn? Let's turn by 45 degrees. Then we draw the other square, and that other square again draws another square until it hits the base case. And afterwards, we turn back the 45 degrees. So let's try this with 180 degrees. And now it gets a little bit more interesting what gets drawn. You kind of get these little windmills. And in fact, what I'm going to do is I'm just going to turbo this up, and we can see, get this interesting turbo shape. So when we have this kind of thing that's turned 45 degrees, that's kind of something that looks symmetrical. What happens if we turn any kind of degrees? So we could make this into another input. We could say with angle, and then we want to make the other angle another input. It'll be another number. So here we just turn whichever angle we give it. Oh, let's apply this so we already have it. So we turn the angle, then we schlep the angle along to our recursive call, and then we turn it back the angle. So what was 45 degrees now is now any angle. Let's try this with 25 degrees. And actually, I'm going to turbo it right away. Oh, that's also an interesting shape. So let's try it with maybe just 12 degrees. Oh, look at that. So whenever I have something like that, where I want to try different angles to see different shapes, it's a fun idea to say, now, what would happen if I tried all the different angles that are possible? So what if, we just put a forever block around here, and, we make a variable, and the variable is the angle, and we draw it with that angle, and then we increment the angle afterwards. Now we want to make this very fast. So we can always see the whole fractal. So in order to make something very fast, we can use the turbo block. Or if we just want to make the stuff fast that's being drawn, we can also use the warp block. Now here's the warp block. So this means that everything that's inside the forever block is going to be drawn in one frame. And just for good measure, I'd like to also hide the sprite again. I can do this. And I'm going to actually put the green flag on top. And now try this out. Let's try this out. So here's got this kind of interesting, almost flowery petal-like animation of an unfolding square fractal that iterates through a lot of angles and keeps producing interesting tiled shapes, almost like trees or like patterns, a square of squares, sort of a sunflower, a tree of grammatical forms. And this is the kind of stuff that I'm excited about. I'm also excited about all the colors, but boy, fractals, they're my love. Now I'm going to hand it back to Jadga.
Yeah, great. So a few closing remarks. First, I fixed the thing. Let me show. You just had to move it 240 steps down in the y direction, or up in the y direction, because that's where our sprite were while we made the costumes. Now you can see that I can cycle through all the costumes that I took as snapshots while we ran the project, and I can just animate them back using the next costume wait forever loop. So it animates the progression of my sediment project. So that's how you could do the GIF from it. And as a closing remark, I just wanted to mention, as you recall, this was just all a square. So I'd really encourage you to explore simple forms and think about stuff that you can do with them. So a super simple shape like a square offers a variety of projects that you can do with them. And it's projects that people or different kinds of people might be interested in. So you can do environmental data visualization, you can do art things, you can do interactive things, and that's all just from squares. Think of what you can do from a pentagon. Wow. So really try out things and also show them to your kids, to your kids' teachers, to whoever you like. To your dog, so everyone who's interested. And thanks for tuning in. If you have any questions, now's the time to ask. If not, you can also find us on Twitter and ask your questions there. Thanks.
Thank you, Jadga. Thank you, Jens. Actually, there was one question at the end. Is this block programming like arranging flowcharts? So you can see that there are SAP consultants who think in the space of flowcharts and workflows and so on, and now you're showing them this block programming, and they're just like, is it something similar?
Maybe Jens, you want to take that question. I will stop sharing my screen. Maybe you want to show something.
No, I don't want to show something. I mean, is it similar to flowcharts? Well, sure. I mean, in a flowchart, you're also expressing something. Usually at SAP, you're showing a process, and I have to try not to make jokes of how we pronounce processes in Germany, but so yeah, it's a process, and the process is something that modifies data. So computer scientists are the ones in charge of processes. This computer science really is the science of process. So that's one of SAP's great, contributions, is to bringing process to business. And so it wasn't there; it was in computer science first. So yeah, sure, it's kind of the same as in the flowchart. There are different representations. Often what you'll see is when people say they're designers of a process, they're more interested in data flow or in the flow of responsibility. So they draw boxes and arrows representing the flow of something. That is one way to look at it. Now, when you're a computer scientist, when you're looking at programming, what you're more interested in is the flow of control rather than the flow of data, because in computer science, data is something that is an argument to a function, and they're really it's not a physical way to think about data flow, because data is abstract. So yes, there are modeling languages. I think business process model notation is one of those, and we've also done some of those, but Snap really is a pretty much literal translation of just a powerful textual programming language into blocks. So it's not really the graphical arrangement that's special. It looks pretty much like any other programming language, stacks from the top to the bottom, and some loops that are visualized by kind of shifting the underlying inside the body to the right. So yeah, it's really a control flow language.
I forgot one really important thing. Can I show my screen again for 30 seconds?
Sure.
because now that you've created all this great artwork or will create it later, there's a way to export it. And I didn't mention that. If you right click on the stage, so this is not the most beautiful thing that we've done today anyway. If you right click the stage and select pick, you can get a picture from your current stage with everything that's drawn and shown on it. So if you create something really beautiful, you can then export it to put it up on your living room wall. Also, if you want to do things in a higher resolution in the settings menu, you can also change the stage size. Don't make it bigger than your actual screen, but you could, for example, change this to 700 times 700 or so, and then you get a really big stage, and you can make it smaller and draw everything again, and then you can change the resolution and the size of your drawing. So that's what I wanted to mention. Sorry for forgetting it.
Oh, that's cool. And actually, to this earlier question, is it possible to export this as GIF, or is it possible to export this as video? Let us just remind what Jens said during the morning session. This is open source project, right? So if someone is coming with the idea that it would be really cool to generate GIF or GIF, let's not get into this discussion, then yeah, just come up with the idea and contribute to the code. This might be an interesting extension. We are at the top of the hour. Jens, any last 30 seconds that you forgot to mention during this hour as well?
No, thanks for being here, for being interested in what we do, and for sharing, hopefully, our passion about squares and programming.
Actually, you made me passionate, not about the square maybe, but I just remember that there is this Polish artist from like 100 years ago who actually did this art called rhythmic lines, yeah, and maybe weekend is coming and I should look into this, or maybe after TechEd, because it's still busy before TechEd, and try to reproduce some of these using Snap. So as I mentioned, we are at the end of the hour. Let's wrap it up. So once again, Jens, Jadga, thank you so much for this great finish of great week. And there was one idea mentioned in the chat that next year maybe we should include actually some tutorials how to use Snap into Devtoberfest, and maybe we can even come up with some coding challenge with Snap for next year Devtoberfest. So with that, I would like to thank everyone who joined this session live or who is watching this later on for joining. This was a great week, but every great thing is coming to the end, but there are good things coming after great things, and this good thing is weekend is starting, at least for me. So everyone, thanks again for joining, and tune in next week where my colleague Marius Albert will be hosting the user interface topic. Take care for now.